Jai Hind and welcome to all. So, from this lecture, I am going to deliver a concept of polymers, and in this lecture, I will discuss the introduction and classification of polymer. To make these slides, I took the help of two books, Engineering Chemistry by Jan and Jain and Engineering Chemistry by Shashi Chawla. And to make the slides, I also took the help of NPTEL site, that is www.nptel.ac.in. So, before the introduction and classification of polymer, I will just give brief historical background of polymer. So, the first question arises, why we need to study to the importance or about the polymer. So, if we go back about the ages of mankind, we will see that human civilization marked by several ages and which are based on material, and these ages are first Stone Age and then second Bronze Age and third Iron Age and fourth, which is now it is Polymer Age. Or obviously, if we see the further, then there is a age of elements like uranium, zirconium, etc. But now we are in Polymer Age. Lord Alexander, and he got the Nobel Prize in 1957, and then he said, I am inclined to think that the development of polymerization is perhaps the biggest thing that chemistry has done, where it has the biggest effect on everyday life. Now, you know that the polymers are one of the most important materials in everyday life. So, we can say that the polymers are very useful, and these are the one of the most important material in everyday life. As the student of science or technology, you must know about the basic concept or basic understanding of the polymers, that you are from the which discipline or you are doing which type of research work or etc. But the basic understanding actually very much essential for quality or for success in life. So, I think it is clear that polymer is used in everyday life. Just if we start our day from the morning, then we brush our teeth. So, the material which is from which the brush is formed, it is bristle, it is plastic, it is polymer. And when we go to the school or college, then the bag, shoes, even books and or even table, chair, all these things, they belongs to polymers. And if we see the medical science, then the equipment which are used in a medical purpose, for medical purposes, they are also made from polymer, whether they are seen or not. For example, syringe we can see, but the material for stitching in operation theatre, for artificial heart, these things which are made from polymer, but we can't see directly them. So, we can say the polymer materials which are used in everyday life, we can see them directly or indirectly. And why the polymers are very popular and why these are basically indispensable in everyday life? These are the desired properties of material which we want. High strength because of load bearing capability. Second is resilience because of comfort giving capacity. Transparency, we can see through the material, and lower cost. None of the non-polymeric material have all these type of properties in a one or simultaneously, but the synthetic polymers which we made according to our requirement, they can have these type of property in a single polymer or simultaneously. So, and nowadays we can see that the conventional materials, these are replaced by the polymer material, And do not be confused in plastic and polymer. We know that all the plastics are polymers, but its reverse is not necessary. That is, we can say that all polymers are not plastics. Polymers are of different type, they have wide range. So, plastic is one of them, but there are other polymers like rubber, like fiber, elastomers is a rubber, or like synthetic polymers, synthetic means inorganic polymers or etc. And these polymers, and because of these properties, they are used in various fields, like for domestic purpose. In domestic purpose, we can see pipes, ropes, brush, even container, even vessels or etc. For transportation, nowadays composites are used. Infrastructure, building materials, industries and medical equipment. And in medical field, lots of polymers are used. So, if we see that from the initial, when the civilization occurred, then the natural compounds or natural materials are used as a polymers, and for various purposes natural materials are exploited. But in 19th century, in 1907, the first polymer which was prepared in lab, it was bakelite. Before this, which type of natural polymer, like suppose rubber, natural rubber, suppose natural rubbers are used as a polymer, everybody knows, for various purposes. And Goodyear scientists, Goodyear discovered that if natural rubber are mixed with sulfur and then heated at high temperature 100 to 140 degree centigrade, then its property like temperature range, like elasticity can change, which is termed vulcanization. So, it means the exploitation of this natural rubber in terms of vulcanization, it was used. But after 19th century, in 1907, there are lots of polymers which were used, and if we see in form of rubber, then various rubbers like Buna S, Buna N, these type of rubbers were synthesized. So, in 1826, the Faraday was puzzled by the fact that ethylene and butene both are differed in gas densities, but they are same in element composition. So, the first word which was basically discovered, it was polymer, and it was introduced by Swedish chemist J.J. Berzelius. And then he considered, and then he said that for example, that butene, it is a polymer of ethylene. It means if we join the two molecules of ethylene, then the butene get occur, and same for acetylene, from this benzene can be formed. Then Schrodinger adapted the definition of Berzelius, and then he described that the polystyrene is a polymer of styrene, but he did not accept the definition for the products of polycondensation. So, later it was Caratherus in 1929 who defined that the substance, basically the sample as a collection of molecule, and they can be represented in form of chain like RRR, and the R, it must be bivalent. So, basically this was the discovery, and then after this the term monomer, polymer, polymerization and various terms it was known. Now, come to the polymer. So, if we see that what are the polymer materials? So, we can say that the polymers are the diverse group of engineering materials, and they are the main components of plastics, rubbers, even resins, adhesives, paints or etc. And these materials have distinctive microstructures built from macromolecular chains and network of carbon and other light elements. So, let us start the terms which are used in polymers and the introduction to polymer. So, polymer means, polymer is a Greek word and which is made from poly plus mers. Poly means many and mers means molecule. So, the structure or heavy weight or higher weight molecule which is formed by combination of many molecules in form of chain is called polymers. And if we compare the properties of single and polymer, then we can see when the molecules are in single form like as a rice, then they can basically shows their properties independently and they can't be entangled or they can't be basically mingled. But when the long chain is formed like a noodles, so when the long chain is formed, then we see that they basically their properties, or we can say the single chain, it does not show independent property. So, they show the combined property and their properties get changed. The same thing, or suppose we can say if we make a chain or a safety pin, a single safety pin, and then we can make a chain of various safety pin, then we see that the single safety pin has different application or different properties as compared to this chain. So, polymer is a long chain molecules formed by the joining of thousands of small units. For example, polythene. If we take a ethene, that is CH2 double bond CH2, and if we combine this ethene molecule in terms of hundreds or 1000 molecules, let n, then we get a chain in which double bond it gets singled and so addition reaction gets started. So, in this case CH2 double bond CH2 is a single molecule and there are lots of or 1000 in hundreds ethene molecules which are termed monomers, and when they are lined up or entangled in a chain, then this is called polythene, which is a polymer. And if we see the properties of both this CH2 double bond CH2 and this has higher or wide temperature range as compared to this ethene molecule. So, the basically polymer means a long chain or macromolecules and monomer is the unit from which polymer is formed. If we take the molecular weight, its molecular weight is comparatively lower, it is about 24 plus 2 plus 2, that is 28, and its molecular is about 1500 to lakhs, because in number of thousands and 100 molecules they get joined. So, this is a monomer and this is a polymer. Now, polymers can be classified as man-made or synthetic polymer, or we combine this, that is biological polymer. Synthetic polymer. Synthetic polymer means which are synthesized or which can be synthesized in laboratory, like even all type of artificial body parts, nylon, polystyrene, PVC, polyester or etc. While the biological polymers means they are directly occur or they are found in nature. So, they may be natural polymers or biopolymers. Natural polymers like natural rubber, like cellulose, wood, etc. And biopolymers which are found in our body, proteins, enzymes, nucleic acids, carbohydrates, lipids or etc. Now, the first term I think it is clear that monomer is the smallest unit or small molecules which combine with each other to form a long chain, and the long chain is called polymers. Now, third term is the polymerization. So, the polymerization is the process through which monomer convert into polymer or through which a polymer is formed is called polymerization. And polymerization, it is of different type like addition, condensation, emulsion or etc. But in this case we take the example of polythene. So, sorry, it is a single bond. So, the process of this formation of this polythene, it is termed as a polymerization. Now, next term, next definition is degree of polymerization, which is dP. The degree of polymerization is the number of repeating unit. The number of repeating unit means, suppose here styrene is there and N molecule of this styrene, they are used to make a chain, and the chain which is formed is called polystyrene. So, N is the, it is called degree of polymerization. And if we see the dependence of mechanical strength of commercial polymer on dP, so for this if we draw a plot in between mechanical strength and degree of polymerization, generally we took average degree of polymerization. So, we get this type of behavior, and this type of behavior for almost all commercial polymer is same, but the value is different, and this value, this point, it is termed as threshold degree of polymerization, and this is a degree of polymerization, we can say desirable degree of polymerization for to be used as for the commercially, that is commercial polymerization. So, if we see before this, let us clear that what is the threshold degree of polymerization. It is the minimum value of degree of polymerization. Below this, the material cannot act as a polymer, that it will be a liquid or in some resin form. So, threshold degree of polymerization is the required value for a material to be act as a polymer. So, if we see the degree of polymerization value of two polymer, let us cellulose or vinyl polymer, the behavior is same, but the value is different. So, if we compare the cellulose and vinyl polymer, the threshold of degree of polymerization of cellulose is about 60, while for vinyl polymer is the 100. And if we see the desirable degree of polymerization for to be for this value, so that it act as a commercial polymer, it is 250 and 400. So, I think it is clear that the mechanical strength and degree of polymerization, if we correlate this, so we get this type of value, and this value is different for different material. Now, if suppose examiner ask calculate the degree of polymerization. So, it is clear that degree of polymerization N is the number of repeating unit. N means basically we can say the number of repeating unit, and if the monomer is of single type, then the number of repeating unit, it will be structural unit, because one unit is repeated again and again. But if more than one monomers are there, suppose in nylon 6, in nylon 6 two type of monomers are used. First is adipic acid and second is hexamethylene diamine. So, when we talk about this nylon 6, here we see that the N is the number of repeating unit, but in number of repeating unit, since the structural units are 2, so which is equal to 2 into structural unit. I think it is clear that if we see a single macromolecules like PVC, like suppose polystyrene, in this case that repeating unit is single or same. So, in that case number of repeating unit will also be equal to number of structural unit. But if we see the oligopolymer or a polymer which are formed by two different monomers, so in that case N will be repeating unit, and which is equal to 2 into structural unit. For example, we take a PET, it is a polyester, and one example we take polystyrene, and polystyrene is benzene and then CH double bond CH2, CH double bond CH double bond now convert into single bond and then N. And please sorry, this is the correction, there is no double bond, there is a single bond. So, we take a two example, this compound or this polymer, it is formed by single. So, in that case N is the repeating unit and which is equal to structural unit, but in this case it is made by two type of monomers. So, here will be repeating, here the repeating unit will be 2 into structural unit. And suppose question is calculate the degree of polymerization, average degree of polymerization we can say, calculate the average degree of polymerization of these two example if the average molecular weight is suppose 1 lakh, like this. Okay. So, in this case the molecular weight of single monomer is 104. So, what will be the degree of polymerization is first structural unit if we find N. So, N will be average molecular weight, that is 1 lakh divided by 104, and this N will be repeating unit, or we can say here degree of polymerization this. But for this PET, it is a polyester, terylene or dacron. We will discuss its structure, properties in next two lectures. In this case PET, the molecular weight it's 192. So, if we find N, so N will be average molecular weight of polymer which is 1 lakh divided by molecular weight which is 192, but this is the structural unit, that is N, and if we find the degree of polymerization then it will be 2 into this, because here the repeating unit and the structural unit, if we correlate this, then the repeating unit will be 2 into structural unit. So, in this case multiply by 2, in this case multiply by 1. Now, the next is functionality, and this term it is important because if a molecule act as a monomer, that it must have at least by two functionality. For example, if we suppose one person want to play a chain, and when he will be able to play chain when it put his hand in both direction, that is in left direction as well as right direction. That is, to make a chain, a person should have at least two hands in both direction. Similarly, if we check up for a molecule to act as a monomer or to make a chain, the molecule must be at least bifunctional, that is its functionality should be minimum 2. For example, CH4, I took this image from the Shashi Chawla. For example, in CH4, CH4 is the saturated compound. Saturated compound means it does not want to combine with anybody, so its functionality is 0. CH3Cl, there is only one group. One group is means its functionality is 1. For example, CH2OH, single bond CH2OH. Now, there are two functional group. A two functional group means the chain it can form from here as well as from there. Since there are two functional groups, so its functionality is 2. This CH4 and this CH3, they are not able to form a chain. It means they will not act as a monomer. While for this compound, the chain can be formed, it means it will act as a monomer. So, I think it should be clear that to act as a monomer, the molecule should be at least bifunctional. So, what is the functionality? Functionality is the number of functional groups or number of bonding sites or number of reactive sites. And the functionalities plays very important role for structure. For example, a molecule which has only two functionality, it means the chain will form in left as well as in right direction. That is, which type of structure or which type of chain is formed? A straight chain will form. This, there are molecules, this is bifunctional as well as this is bifunctional, and when this combined, so linear chain or straight chain polymer get formed. But if the molecule has more than two functionality, suppose functionality is 3, functionality is 3 means this, this and this. So, the attack can from 3 side, and when it form a chain, so it means the chain get formed from all 3 direction. It means which type of a structure get formed? Either branch structure or cross-link structure get formed. So, if the functionality is 2, means linear structure or linear chain get formed, and if functionality is 3, it means branch or cross-link polymer or chain get formed. For example, in case of phenol, if we see the OH group, so there is only one OH group, it means it is monofunctional, means it will not act as a monomer. But if we see the reaction due to this benzene ring, and we know that phenol is ortho-para directing, that is the molecule or the chain, it can be from at ortho position as well as para position. So, in benzene ring there are two ortho and one para. So, 3 sites are available for attack. So, we get a cross-link structure, and the polymer which is formed by phenol and formaldehyde, it is bakelite. So, phenol due to OH no monomer, but if we check the linkage due to this benzene ring, so 3 sites are available. So, cross-link structure will form. Now, classification. So, polymers are classified on the basis of various properties of various types. So, we discuss one by one. First, let on the basis of structure. On the basis of structure, it may be linear, it may be branch, it may be cross-link, or it may be 3D network or it like a web. But if for example, let us take an example of polythene. Polythene, if we take whether it show linear structure or branch structure, it will always show its structure like this. But if polythene is arranged in such a manner that packing is not efficient. So, if packing is not efficient, that is density decreases. So, which type of polythene we get? Linear low density polythene get formed. So, if the examiner this question arises, then what is the structure of LDPE? So, immediately think about this, that LDPE means lower density. Lower density means packing is not efficient. Packing is not efficient means which type of structure it is? Branch structure. Just imagine if you are going somewhere, or suppose in your hostel, and you put your clothes unpressed, then we see that in bag very less amount of clothes it will basically there. So, it means space it will occupy comparatively, it is large. So, density mass upon volume. So, volume more, that is density, it become less. But if we see HDPE, that is high density polythene. So, immediately think high density means pressed cloth or we can say the packing is efficient, and packing is efficient means the structure linear. So, LDPE has branch structure, while HDPE has which type of structure? Linear structure. Crosslink, very good example, vulcanization, natural rubber initially branch, but when we mix them with sulfur, then sulfur it basically link between the chain, and when it link between the chain, then we get which type of a structure? Crosslink structure. And network, we take generally thermosetting, Kevlar, epoxy or etc. Now, next is on the basis of tacticity. Tacticity means stereochemistry, or we can say spatial arrangement. So, if we classify the polymer on the basis of tacticity, then we can see that it is the arrangement may be of three types. First is isotactic, this. Second is syndiotactic, this, and third is atactic. So, tacticity means spatial arrangement, or we can say stereochemistry of the polymer. Isotactic arrangement. Isotactic arrangement means in a polymer chain, if the same groups are on same side or the groups are lined up on the same side, then it arrangement or its type is called isotactic. And isotactic polymerization or isotactic polymer, to make this, either we have to take high temperature or high pressure, because this type of arrangement is very difficult, or we have to take Ziegler-Natta catalyst. So, remember this, that to make isotactic polymer, which type of polymer is used? Ziegler-Natta. It is a coordination polymer and TiCl4 AlR3, like this. So, isotactic means symmetrical arrangement. Suppose this is a polymer chain. So, here we see that they are on same side. Next is syndiotactic. If the structure is like that the same group are on alternate manner, means suppose this R is not here and we get R here. So, in this case R this, then this and then this, that is they are in side to side position, in an alternate position, then this type of arrangement is called syndiotactic. Atactic means any type of arrangement is there. Suppose this is a polymer chain H, R, but in second we get R here, but in third again we get R here. So, in this case we see that the arrangement of R or arrangement of group is not in either same or in alternate manner, that is randomly. So, this type of arrangement is called atactic polymer, and generally we find this tacticity in homopolymer, and this homo and this classification we will read in I will discuss in next lecture. So, on the basis of tacticity, iso, syndio and atactic. Now, I am finished this lecture here, and in next lecture we will continue this. Thank you.